Hi. Another definition within statistics is the margin of error, and that tells us how sure we actually are about something. Margin of error is a value that we can calculate, and this is the official definition. It gives us a limit on how much the responses of the sample would differ from the responses of the population, where the population is everyone that we want to know something about, and the sample is just a group that we survey. For example, if 40% of the people in a poll prefer candidate A and the margin of error is plus minus 4%, then it is likely that between 36 and 44% of the entire population will prefer candidate A. Right? So somewhere in between 36 and 44% will be the real percentage of the entire population, even though the sample that we looked at only gave us 40%. Margin of error gives us a little bit of room because our sample might be different from the population. Right? If we take a sample, because taking a survey from every person in the population is really difficult. You don't have enough money, they're too far apart, there are too many people, or you just don't have enough time. Now, well, there are several other reasons to actually do this, but most of the time take a sample of the entire population because it's just easier. And that's why a sample might be different from the whole population because it's a small group. Margin of error is calculated with plus minus 1 over the square root of n, where n is the size of our sample. And the percentage of the population that would have the same opinion is most likely to be between p minus 1 over the square root of n and p plus 1 over the square root of n. And these are percentages, and they're written in decimals. You always need to remember that. Right, for example, students in a high school will vote on a proposal to start classes late in the day. According to a survey for a random sample of 400 students, 54% of the students agree with the proposal and 46% of the students disagree with the proposal. And the question is, does the survey clearly show what the majority of the students think? All right, let's see what we can do. 400 students, 54 and 46, those are all of the values that we find in this example. And I always like to look at just the numbers before we actually start calculating. So the survey was from 400 students, so n is 400. Our sample size is 400. The margin of error is calculated by plus minus 1 over the square root of 400, which gives us a value of 0.05. Right? It is margin of error is always plus minus, so it's plus minus 0.05. And remember, your calculator will not show you plus minus. You got to do that yourself. Classes start later. There were 54% of the 400 students agreed, 46 disagreed. The margin of error means that the population percentages will be 5% higher or lower than the sample. Right? That's what the margin of error tells us, that somewhere in between 5% higher and 5% lower of the actual outcome from our sample will be the percentages of the population. Right? So for population, we can calculate in between what two values, what two percentages the students in a population will agree. Right? And we do that with the margin of error. In this case, 54% of the students in our sample agreed. So with the margin of error, that gives us 54% plus minus 5. So in between 49% and 59% of the whole school population would agree. And that actually doesn't assure us of a majority, because 49% could be a minority, meaning that in that case, the majority would disagree. So we cannot be sure with these values if we actually know what the population is. There's a couple things that we can do. Is if you do this and you're trying to be sure, you can increase the size of your sample. So instead of 400, we can take a sample of 1,000 students in a really big school, and then the margin of error will be smaller. And those are things that we can think about. Remember the formula, and thanks for watching.